Okay, so today's opener covers the notes that we took yesterday using rectangular area models backwards. And it also is just a short, just a short review of finding the greatest common factor for each expression as well. So, the first problem that we're going to look at, we're going to go through and just identify where everything goes, just as a refresher. So when I'm looking at a number up against parentheses or two set of parentheses, that's going to identify the what. When I see a number up against parentheses, what's that talking about for the area rectangle? For the model. It's going to represent the what and the what of the rectangle. Sorry, it wasn't a very clear question. The height and width. So the first number or set of numbers represents our height. Then the second set of numbers represents our width. Okay? Then if I have numbers that don't have parentheses around them, those are going to represent the area. So we need to plug in what we know onto our model and then find out what we don't know. What don't we know? The width. Okay? So we know the height. So what's the height of my rectangle?
6A.
So 6A. And we know the area of my rectangle. So what's the area of the first section?
24.
And the area of my second section?
18A.
Bless you.
Thank you.
Okay. So now I need to find the width. What's the formula for finding area of a rectangle? What's the formula for finding the area of a rectangle? Area equals what times what? So height times width. So if I know the height of my rectangle, is 6A, I'm going to go ahead and plug that in for both sections because they're going to have the same height. So now I need to find the width for each rectangle. So I have to think to myself, the height times the width will get me to 24A squared. I know the height is 6A. I need to find the width. So 6 times what will get me to 24? 6 times what will get me to 24? 6
squared.
I don't want all that. Listen to the question I'm asking. 6 times what will get me to 24? 4.
Well, you have to have that.
Hold up. Give me a second. So now I have 1A up here. The reason why I'm doing step by step, because I'm going to throw some really long ones at you coming up. So when I have 1A up here and 2 down here, how many more A's do I need? 1. So the width of this section is 4A. So I'm going to make sure I label my rectangle in all the appropriate places. So now I need to find the width of my second rectangle. 6 times what will get me to 18? 3. Now, I have 1A up here, and my answer only has 1A. So do I need to add any more A's here? No. So the width is just, what's my width? 3. So when I go to plug in my numbers into the blanks, am I going to put the 3 first or the 4A first? Yeah. So make sure you just put them in order. So the 4A goes directly up, then the 3 goes in the second spot. Key things that you need to remember to do. Make sure you're showing me all of your work. Don't just put this and this and then your width. So don't just put your height, your area, and your width. Make sure you're showing me the work inside each section of the rectangle. Okay? Any questions on that? I felt like when I walked around, most of you guys had that one. This is the fun one, though, right? Yeah. This is the one where it's a little more confusing. I promise you, I'm going to give you some shortcuts or helpful hints or guidance in the upcoming week or so to help you solve this a little more quickly and efficiently. But for now, we're going to do it the long way. Okay, so the first set of numbers that have parentheses are going to be my height and my width. They only give me one height. What's my height? So that's going to go for my first rectangle. So if the height of this rectangle is 5C, I also know the height of this rectangle, which is. So I'm going to go ahead and plug that in. So the height, because the height always goes first. Okay. They don't give me any other heights. They don't give me any other widths. So I'm going to move on to the next section. The next section is going to be the area of each rectangle. So 15C squared is usually the area of which section of the rectangle. When I say section, I always count from left to right. 1, 2, 3, 4. Okay? So when I'm asking you for which section of the rectangle, 1, 2, 3, 4. So which section of the rectangle is 15c squared going to be in? 1. So my area is 15c squared. Okay? The second area, 43c. What section of the rectangle does 43c go into? 3 and 2. So we're going to have to split 43c. We're going to have to do some guesswork over here to the right in a moment to determine what numbers I'm going to use in order to get 43c. Because it's going to be combined like terms. We're going to have to add the two total areas in order to get 43c. So then the area of 8 goes in my, which section of the rectangle?
4.
The fourth spot, yeah. The bottom right. Okay. I can find a couple more things here. Before I start my guesswork, I can find a couple more things. What else can I determine?
The first box.
I can go ahead and solve for my first section. So what do I mean when I say solve for my first section? What am I finding?
Find out what equals
Width.
15.
The width. Good. So I have to think 5 times what gets me to 15? 3. I have 1c up here, but I need 2, so I'm going to put one more c in. So the width of the rectangle is 3c. So I'm going to label that. So I don't go, I always label right when I do it so I don't forget. So if I know the width of one rectangle, I'm also going to know the width of another rectangle. What's the width of the other rectangle I know? Do I know the width of 1, 2, 3, or 4 now? 3. Because the width up here is going to be the same width down here, which will be, okay? But that's all I can do now without doing my guesswork. So, what I do now, I come to my area of 8. I have to think of everything that I can multiply together to get 8. So I need to think of my factor pairs. So my factor pairs for 8 are
4 and 2.
what else?
1, 8.
And
That's it.
1 and 8. Well, let's do 8 and 1 backwards. Okay. Now, I'm going to use this first group. I'm going to plug in the 1 here and the 8 here. Okay? So I'm going to take 5c times 1, and what do I get? What's 5? What's 5 times 1?
5.
Okay? And then I'm going to take 3 times 8. What do I get?
24.
Now, don't forget, it will have a variable on it, but just for the sake of doing shortcuts, we're going on. So what do I do with that 5 and 24 now? Does 24 plus 5 get me to 43? So that does not work. So I go to the next one, 2 and 4. So I'm going to take 5 times 2 and get, and then I'm going to take 3 times 4 and get, okay, 12 and 10, does that equal 43?
No.
Moving right along. So now I'm going to use my factors 4 and 2. 5 times 4 gets,
30.
how about 20?
Yeah, 20.
3 times 2 is 6. So what's 20 plus 6?
20.
Doubly not enough.
Yeah.
So let's see if our next one works. 8 and 1. What's 5 times 8?
40.
And then what's 1 times 3? 40 plus 3, does that get... So, we have to use them in the order that we have them written. So the first one I plug in is 8. And then the second number I plug in is 1. So now we can go ahead and finish filling out our model. So what's the width of this rectangle?
8.
Okay, so I'm just going to bring that up. And then I'm going to bring it, if that's the width of this rectangle, it's also the width of the rectangle directly behind it. So I'm going to bring that down. So what's the height of this rectangle now?
1.
1. So I'm just going to go ahead and write those in. So the height is 1, the height is 1. All right? So then I'm going to finish up my areas. So what's 5C times 8?
40.
40 what?
C.
Okay. And then 1 times 3C.
3C.
And then we already said 40C plus 3C will in fact get me 43C. Now I just need to fill in my blanks up at the top for my height and widths. So what's the second height I need to plug in? No, the height.
1.
The 1. Then my width for now is going to be
8.
8. So make sure on your opener you have your heights all labeled on the outside. You have your height times your width in your areas in each section. Okay? Show all of your work.
How do you next one?
Flip yours back over. You're missing one thing. You're missing the height on your area model.
Got it.
On your area. Oh, you got it now. Now you got it. Okay. Now we're going to find the greatest common factor for each expression. So the first thing I'm going to do is use my prime factorization sheet, my little cheat sheet, because it makes it go a little bit faster. And I'm going to write out all my prime factors for each of the following numbers.
How do you do some?
All right, Tanisha, what do I have for 18?
2 times 3. The next one. 2 times 2 times 3 times 5. And
Okay, hold on real fast. So 150 was not on our sheet.
Can I do that?
So Tanisha, do the prime factor tree for me.
15 times 10. And then 15 will get 3 times 5. And then 10 will get 5, 2.
So what I would do on your sheets, I would put 150 on your sheet somewhere, and I would write the prime factors out. So I'd write 2 times 3 times 5 times 5. Use that as a divider. So I would write that somewhere on your blue prime factor sheet if you don't have it already.
I didn't get 3. I got 5. I did 5 and 10, 5 and 100, and then broke that down.
5 and 100, you can't do because you only 500. You can't do 5 and 100. Can I show you a cheat? Let me show you a cheat thing too. How you can find out if you did it right? Take 2 times 2 times 5 times 5 times 5. Does that multiply together to get
Yes.
150? No, it doesn't. No, it doesn't.
I'm creating it.
No, it doesn't. Okay. Okay. So my prime factors for 150, I just listed them. We have. Did you say 10? Why would 10 not be a prime factor?
Oh, shit.
You are tripping. Okay, my 5s got bigger as I kept writing. Now, I need to circle the prime factors that all 3 numbers have in common. They all have to share it. So what are my prime factors they have in common?
2.
2
3.
And
and a group of 3s.
and that does.
But
Is
where
that
did
it?
come from? Yeah, that's it.
Okay, so that's it. So then I'm going to come to the right here. I'm going to write GCF, greatest common factor. So I have a group of 2s in common and a group of 3s in common,
2 times 3.
which will be,
6.
so I'm going to take 2 times 3,
Dang.
which is 6.
And then you gotta add your variables.
Okay, so do they all have an x in common?
Yes.
What is the what is the variable with the smallest exponent?
X2. X is X.
Good. All right, let's look at our y's. Do they all have a y in common?
Yes.
What's the smallest exponent?
Y to the second power.
And do they all have a z in common?
Yes.
What is the smallest exponent?
3. X.
Hey, Kijan, please stop shouting out things that are incorrect.
I forgot my 3.
You do not, I'm going to circle it, underline it in green. You do not need to write that part out in order to receive credit. I did it just to show you how I got the number 6. So that's not necessarily something that you have to have written out. Dylan, question?
I do it first, the 2 and 3, and then equals 6, and then the answer.
You want to show me what you're talking about?
I think he's saying like what you got.
So you-
Income factor 2 times 3 equals 6.
Yeah. Yeah, that's totally acceptable. Okay, so let's take a look at the next one. So we have 3 terms here. When I say 3 terms, do you guys understand what I'm talking about?
Yeah.
So this would be a term, this would be a term, this would be a term. So I have 3 terms. So I have 3 coefficients. When I say a coefficient, what do I mean by that?
the letters.
Just letters or variables.
Oh, the numbers.
Numbers.
Yeah, the
I
numbers.
told you.
So I have 3 coefficients. I have 50. I have 45. What's my third coefficient?
B5.
Because that's a number. 1. So what are your prime factors for 50? Paige, what are my prime factors for 50?
2 times 5 times 5.
And for 45? Paige?
35.
And what are your prime factors for 1? Yeah, 1. So, do these coefficients, do they share a common number?
Yes.
Yeah, what do they share? 1. Because every number shares the number 1. So my greatest common factor for my number is 1. Now, I look at my variables. Do they all 3 share or have in common an A?
No.
Do they all have a B in common?
No.
Do they all have a C in common?
No.
So my greatest common factor is just
1.
1. Any questions?
No, ma'am.
All right, nice job.